In this video series, we are going to study science chapters of grade 10 SEE exams. Now we are going to start a physics chapter, light. So in this series, we have been solving questions of your set book, one of your set books. But now we are going to discuss important topics of chapter light. For example, construction of ray diagram. This is very important. We are going to, just discuss the construction of ray diagrams, right? And we'll be doing defects of vision in the next part, right? So we'll be doing important parts of the chapter. Now, construction of ray diagram by convex lens. So convex lens, there are 6 positions we have to do, and the position, size and the nature of images formed after refraction through lens, convex lens, we are going to see in this part. So you have to study for 6 positions: infinity, focus, 2f, beyond 2f, between f, 2f and f, between f and o, right? So here you see, when the object is at infinity distance, image will be formed at f. You have to remember that this is about position. When the object is placed at f, image will be formed at infinity. These two are opposite to each other. Remember? Okay, remember this way. When object is at 2f, image will be formed at 2f. So easy. Okay, this is easy to understand. Remember, object is at 2f, image is also at 2f. Okay, on either side. Beyond 2f, after 2f, the image will be formed between 2f and f. Between 2f and f. On the other side, 2f and f. Whereas when the object is between 2f and f, image will be formed beyond 2f. Beyond 2f. These two are opposite to each other. Okay, so these 5 positions are easy to remember. Now the last one is between f and o. Between f and o will be on the same side of the lens of the object. On the same side of the object. Because this is virtual, on the same side of the object. Okay, between f and o, this is the special one, this is not like others, so you have to remember this one. Okay, so we'll go to the construction of ray diagram. Before that, you will see the images nature. We'll talk about nature a little bit. The images formed by convex lens will be real as well as virtual. Okay, real means image forming on the other side of the lens. Real, virtual is on the same side of the lens. Okay, it will be enlarged as well as diminished. Enlarged means bigger, diminished means smaller. Okay, it will be bigger as well as smaller depending on the position of the object, right? Whereas for concave lens, when you do concave lens, you will see that the image is always virtual, and if the image is virtual, it is always upright, standing up, and it is always smaller, diminished. Okay, so concave lens can make only this type of images: virtual, upright. If it is virtual, it is always upright and small size. Okay, in case of concave lens. Whereas convex lens, real, if it is real, it is always inverted. Again, real is always inverted. Okay, yes, and it can be enlarged as well as diminished. Yes, so for convex lens, we will see the images from real as well as virtual. It is bigger as well as smaller depending on the position. So we'll focus on this part now. Now we will see, according to positions, object farther than the lens. When the object is far away from the lens, image will be smaller, right? When the object comes closer to the lens, nearer to the lens, then the image will get bigger. Okay, we will see these changes in the ray diagram. And when you start doing ray diagram, you have to remember the rules. The rule is very, very simple. This is principal axis. Yes, this is lens position, right? And you have to consider only 2 light rays. Numerous light rays are coming out, from the object. Yes, there will be numerous rays from the object, but we will take only 2 rays as representative rays. You need to take all the rays. The ray 1 is parallel to the principal axis. Okay, the ray which is parallel to the principal axis will be passing through focus. Okay, this is one rule. Other one is the ray which is passing through optical center will go out undeviated. there will be no bending of the light ray which is passing through optical center O. Okay, so remember these two lines, okay, rules and two lines of light rays. Okay, one is parallel to the principal axis passing through focus on the other side, this one, and the light ray which is passing through optical center will go out undeviated, will pass out undeviated without bending. Okay, just remember these two. Okay, it will be enough. So this is very simple. Now we'll start ray diagram. Now you see, whenever you start doing ray diagram, you should have pencil scale, guri scale. Take a long scale, ruler scale, and make 5 positions on this principal axis. This is principal axis, this is a straight line. Make 5 positions by taking 5 points which are on equidistant from each other. Okay, I suggest you to take 1 inch distance from each point. This is the middle one, this is the first one, third one, number 3, 1 2 3 4 5. This middle one is lens position. Make it lens position, and don't make the height of lens very high. Okay, just you take just more than 2 lines, just little bit more than 2 lines of your notebook. Okay, if you are doing it on notebook, this way, lens position. This is optical center, this is F, this is F, this is 2F, this is 2F. 2F is also referred as C position, okay, because this is center of curvature. C position sometime. 2F is C also. Yes. Now when the object is at infinity distance, it is far away, right? Then the light ray will be parallel to principal axis. Okay, you need not to draw this long lines. Okay, parallel to principal axis. When rays are parallel to principal axis, they will be passing through focus. Make bending right from this point. This bending will put you into trouble because we are not very careful to make bending right from this point. It should not from this side, it should not from little bit that side. Okay, right from this line there should be bending of light ray. So put arrows in light rays because light rays always travel from one point to another point. There is a definite direction for light rays to travel. So if you do not show arrows over here, your diagram will not be complete. Okay, your diagram will not be complete. So it is very important to show the arrows. Okay, direction of light rays, right? So now what we'll do is the light rays are coming from infinity distance because object is at infinity, and the light rays are crossing at focus, means image is forming at this point. The point where 2 lines cross with each other, at that point image will be formed. You know this one, no? So image will be formed at F, and the nature of image will be this is real, and if it is real means inverted. Okay, real, inverted and diminished. Real, inverted, diminished. Diminished means smaller in size, right? Because object is at infinity distance. Farther the distance, smaller is the object. Okay, so real, inverted, diminished, position F, position at focus, right? So this is the ray diagram for first position. Now we will see just opposite of it. When the object is placed at F, yes, when the object is placed at F, when the object is placed at F, lens position, this is F, this is 2F, this is F, this is 2F. Now let the object be at F. You have to give the name to it. This is A, this is B. Now you have to consider 2 light rays, okay, coming out from this point, yes, parallel to the principal axis, bending, going through focus, okay, and passing through the optical center. Yes, so in this case light rays will be traveling to the infinity distance. Image will be formed at infinity distance. Image will be formed at infinity distance, and it will be very much enlarged because bigger. It is very close to the lens. I told you, closer to the lens, bigger is the image, no? So the nature of image will be real, inverted, and magnified. Real, inverted, magnified, and infinity position, because the object is at F, focus. Okay, infinity focus, focus infinity. You have to remember this way. And up to this 5 positions, the image is always real inverted. Okay, this is real inverted, this is real inverted, real inverted, real inverted, real inverted. Only the last position will be virtual erect. Virtual erect, only the last position. Yes. So this way, object at infinity, F, at F the image, object is at F, image at infinity. So these two we have done, right? Now next is, we will do 2F 2F, when the object is placed at 2F. Okay, when the object is placed at 2F. Okay, so when the object is placed at 2F, make a principal axis over here. Yes, and 5 positions on the principal axis, 1 2 3 4 5. These points should be equidistant from each other. Equidistant means equal distance away from each other. This is the lens position. Lens position. Okay, now object is at 2F, F 2F, and this is F 2F, right? So here object is at 2F. Consider 2 rays of light from here and bending right from this point going through focus. Okay, and another one is from optical center. Make it cross right at 2F. Okay, yes, and it is meeting over here. So whenever you draw line, no, from here to here you can draw without any worries, but from here, whenever you do this bending, no, whenever you place a scale at this point to draw this line, you have to be very very careful, and you have to make the adjustment in order to make it cross at the correct position, right? So while bending, while using scale, that bending should be done very very carefully. Okay, so it should be the same size as the object, right? Hopefully it is same size, because I am drawing freehand. A B, and this is A dash B dash. Okay, A dash B dash. This is object is at 2F, image is also at 2F. Okay, yes, this is F, this is 2F position. So object image will be real inverted. It is mostly real inverted in convex lens. Only last position is virtual erect. Okay, and same size as the object, and position is 2F. Okay, done this one. Now we'll go to the object is beyond 2F. Beyond 2F. Now we'll do beyond 2F. Principal axis, draw principal axis. Okay, 5 positions, 1 2 3 4 5. You can take 1 inch difference in the distance. This is lens position. Object is beyond 2F, F 2F. This is F 2F. Object is beyond 2F. Okay, let it be here, right? Consider 2 lines. One ray is, the image will be formed between F and 2F. You have to make it by heart. F and 2F somewhere here, no, somewhere here, right? You have to make it cross at this position, right? So then you join the line. Okay, while drawing this one, you have to use your scale very very carefully. Bending of scale should be done very very carefully. Adjustment, slight adjustment. Okay, so this way the image will be formed at this one. beyond between f and 2f, and it will be smaller than the object a b, a dash position, b dash position, right? So this is the image, okay, between f and 2f, and image will be real inverted. It is mostly real and inverted. All 5 position real and inverted. Smaller, diminished, smaller than the object, or you can write diminished. Smaller, you can write smaller also, and between f and 2f. This is for this one. Now we'll do opposite to this one. Principal axis, lens position, okay, 1 2 f to f, f to f, f to f. This is f to f. Lens position, make the lens. This one, lens position. Yes, the object is between f and 2f. Let it stand over here between f and 2f. Yes, this is object A and B. Consider 2 light rays. One is parallel to the principal axis, other one is passing through O, right? And you have to make image over here beyond 2f, somewhere here, no, and it will be bigger, and it is, this one is passing through focus, and this one is going undeviated, okay. When you do with the help of scale, it will get caught at the right points, okay. You have to be a little bit careful. Okay, anyway, it has crossed at this point, it is okay. So this is A dash, B dash. So the nature of images over here, real inverted, again real inverted and magnified. Smaller over here, this is magnified. Magnified means bigger, magnified, and beyond 2f, beyond 2f. You see, these two are opposite to each other, okay. So this way the diagram for these two positions, right? Now we'll go to the last one, between f and o, and this is the special one, okay. This is not like others, okay. So this is when the object is very close to the lens, then what happens to the image, we will see here. So my principal axis, make 5 positions, 1 2 3 4 5. All these points should be equidistant from each other. Yes, the middle one is lens position, middle one is lens position, this one. This is O, this is F, this is 2F, this is F, this is 2F. Now the object is between F and O. This is A, this is B. Okay, consider 2 light rays. One is parallel to the principal axis passing through focus, no problem, right? Other one is passing through focus and it is going out undeviated without bending. Okay, then over here, these 2 lines are this side. Now produce these lines backward. These are not going to meet at any point this side, so you have to produce this backward. While producing backward, make sure that it is a straight, okay. On the board I am having a little bit difficulty, so then you produce it backward, this also this way, and these 2 lines are seems to be caught at this point. At this point, so image will be formed at this point, okay. This is A dash and B dash, this is image. If your line, these 2 lines gets caught at this point, then this is also correct, this is also correct, this is not mistake, okay. After this line, wherever it gets caught. No, so at that point image will be formed, and this is, it is not necessary that you must make it beyond 2f only. Okay, it can come before 2f also. Okay, this, yes. So the image will be formed at this point a dash b dash, and this one is, you have to show arrows this side only. You need to show arrows, you don't need to show arrow this side. Okay, for this the light rays which are moving that side. Now the nature of image is virtual because it is on same side of the object. Virtual, if it is virtual, it is always erect, means standing up. Okay, and this is magnified. Virtual, erect, magnified, because it is bigger than the object. Virtual, erect, magnified, right? Okay, you need not to write about the position over here. Virtual, erect, magnified, it can be anywhere after the object. Okay, yes, behind the object. So virtual, erect, magnified, this is the nature of the image, right? So this way we can draw ray diagram for convex lens, construction of ray diagram. Now we'll see for concave lens in the next part.